So Sparky, the electric field explorer, is investigating a mysterious setup of concentric spherical shells. The inner shell is a total charge of positive 2q, radii A and B, outer 4q, radii C and D, and Sparky needs to determine the electric field both magnitude and direction in terms of q and the distance r. Now we've got through 5 situations from r less than a to r greater than our last shell, which is D. This is how we would interpret the visualization of the graph. It is, we have your A, B, C, D shells, positive 2q, positive 4q. Now, we see here that because this is a conductor, based on our definition, a conductor's electric field, inside of a conductor, its electric field must be 0, and it is 0. Let's start from number 1, but before that, let's remember electric flux is equal to E dot A can be given as flux equals EA cosine phi. Next one is electric flux is equal to enclosed charge divided by our epsilon naught, which is a constant. What we need here is electric field. We need to determine our electric field, both magnitude and direction. So, given that, let's see here. How do we get our E? We get our E by manipulating the equation from number 1, r less than a, that would be r less than a. This is going to be our r. Now, given that that is our angle would be 0. And because our angle is 0, cosine 0 should be 1. Now, because cosine 0 is 1, then EA cosine 0, 1, then you only have EA. Flux is equal to EA. To get the E, manipulating, we'll have electric field is equal to flux divided by our A. Now our flux is Q enclosed divided by epsilon naught divided by A would be times 1 over A. And if that is the case, we know that the Q enclosed here is 0 because this is the center. We don't have any charge here yet, and also definition of E is equal to 0 if it is a conductor. So your E here mathematically must be 0. Now imagine that we didn't really remember our E is equal to 0 here, or we didn't remember our definition. It would be like this for number 2. But since we already know that E is equal to 0 inside a conductor, then we must have 0 n over c here as well. How would it look like mathematically? Well, it would look like this. This is our R, and the way it would look like is 0 n over c. The way it would look like is the same thing. E is equal to Q enclosed. Here is still 0. You have 2Q here, and this would be negative 2Q, cancelling each other out for the sake of our definition here. So 0 divided by epsilon naught times something, that would just be 0. So for 1 and 2, they're both 0 n over c. Next, for number 3, we have our seashell. Now for our seashell, it says R must be greater than our B, but less than our C. This is our C. Looking at it, we should have this part here. This is our R. R. Now, how do we get our E? Manipulating again, we'll have cosine phi still 0, so that's going to be 1. Electric flux is equal to EA1, still 1. EA, manipulating, that's electric field. Flux divided by A. Flux is Q, enclosed, divided by epsilon naught, all over A. Our Q enclosed in this situation is our positive 2Q. We have Q enclosed divided by epsilon naught all over A. We can therefore substitute values and or simplify. We have 2Q here. Then we'll have epsilon naught here together with our A. A is 4 pi r squared. We can therefore conclude that for number 3, your electric field is 2Q given a Q divided by epsilon naught 4 pi r squared. For letter D is C less than R less than D. That would be this way over here. It's going to be our R. Now, same is true with this one. We still have cosine phi equals to 1. So that's going to be flux is equal to EA still, giving us E is equal to flux divided by A. And then we need to just modify the last part here, which is this one. Q enclosed divided by epsilon naught all over A. Now here, our Q enclosed is given to be supposedly 4Q, but then as we mentioned here, positive 2Q, then it'll be arbitrary negative 2Q in the inside of that. So same is true with this one. We've got 4Q here, 4Q. Still have a negative 4Q here. So they'll just give us an electric field of 0 over there. And because of that, your Q enclosed would be 0 divided by anything multiplied to 1 over A, and that is just going to be 0 n over C. And lastly, number 5, we have R is greater than our D. Now, since our R is greater than our D, we assume that it is here, greater than D. Now, since our R is greater than D, still cosine phi is 0 because 1 because phi is equal to 0. We can use this latter part here, and our Q enclosed would be 4Q plus 2Q, which is 6Q. Multiply to our epsilon naught. Just put it here. Epsilon naught 4 pi r squared. Now 4 pi r squared, it can be calculated, especially when you have r and your 6Q if you do have Q. So for R greater than D, your electric field is given to be as 6Q divided by our constant 4 pi r squared.